So hopefully you can hear me well enough. But today's class is going to be focused on this idea of looking at plan review and taking a little bit deeper dive, looking at those devils in the details that really impact how successful a project can be. And one of those things that we really hit hard is the concept of insulation design. So, as you know, that's kind of the focus of today's webinar. But if you have any questions, please feel free to put them in the chat, raise your hand, put them in the Q&A, and we'll see what we can do to engage in this conversation about plan review specifically. For those of you that maybe this is your first time, you don't know that my name is Josh. I'm with Shums Coda, and we represent or facilitate the Minnesota Energy Code Support Program, which is a program created by the utilities to help support, educate, and empower the building professionals across the state in energy code compliance. We can talk about why they do that when we're together next week. But again, this is something that we have a lot of different states participate and do this kind of work because, again, there is value in community energy code compliance. We have a website. Again, you guys have probably gone there. That's how you found this webinar, Minnesota Energy Code Support Program.org. On that website, we have a variety of different technical resources and documents. And with that, that just triggered him. Oh, let me think about this. No, we got to do this first. And so that's one of those things that if you have any questions about it, feel free to reach out to us. Let us know if there are things that you would like us to facilitate. We'll talk a little bit about some of the stuff that we're doing here in a little bit in the next slide or two. But one of the things that we're trying to do is, again, just be a resource for you, be a free resource, an avenue for you to get some training, to engage, and then also hopefully to provide some technical guidance or not guidance, but again, resources. What we see here on the screen again are some of the different old flyer for some of our trainings. Actually, the last one we did back in May, our first training in May up in Hermantown. There's also our newsletter, which again provides some different resources, and then our inspection guide. Here we go. I'm going to throw into the chat for everybody the slides if anybody wants them, because I know some people like to take notes while we talk. One of the things that we also have just recently, actually Monday, put onto the website is the collaborative document that we've been working with the Minnesota Center for Energy and Environment on, the Build Up Minnesota program that they're operating through the Department of Commerce. And so as part of that, we've created a first draft of a commercial plan review checklist. And so that's available. It's a resource more for, at least in my opinion, and maybe that's where we want to get some feedback from you guys as a team, so that we can refine this. This is a resource that we put together really for the design professional to help guide them through the process of plan review. And then they can submit this with their plans, and it would almost track what pages they've demonstrated compliance with the different components. So if you do go to, because I know you all love it when I go crazy and go to the website. Right, so if you go to the website, click on technical documents, and that for those of you that have never done this before, if you don't know how to, if you get confused with the because that happens sometimes, for me with the Minnesota Energy Code Support.org, you can type in our initials MNECSP.com and it'll take you there. But more importantly, there's a series of different resources available to you. Let me zoom out just a hair. You might be able to better see it. And the very bottom one is going to be that checklist. So when you click on any one of those documents, you'll be able to see some kind of a link either to download it or something like that. This one you click, and it will take you to the website where you can download the checklist. So we're going to add that download. It's a downloadable thing. It's not something you do online. You download it, and that gives you access to this checklist. So we'll talk a little bit more about it. Like I said, it's something we've been working on together as a group, and so I'm going to play with it some more this week, and maybe at one of our future conversations we can talk. But again, there's a variety of different inspection guides. Let's look at this one here. Again, the visual inspection guide. This one's specifically for power and lighting. And so again, it would give you some ideas, some things to look for associated with the power and lighting requirements in the code. So I think, so the one that I think we will kind of reference, look, not necessarily go through hand piece by piece, is going to be this guide here on an insulation. Again, that's going to be a document that you can download, you can print off. We are working on getting a handheld, pocket-sized version of the entire series of documents. That way you can have that and take it with you out on inspections, give it to a contractor, so they have a better idea of what you're expecting to see when you're going out to do a foundation inspection or framing. You're looking for the wall cavity or windows, duct insulation, pipe insulation, verifying the use of a space. We've talked about that a few times, and we'll get into that here today. But again, it gives you some ideas of things to look for in that process. So getting back to what we were here to talk about at the beginning. There. One of the things, obviously, you hear me say it all the time. One of the things that we like to do is I like to remind us why we do what we do, right? And that recognizing why we do it helps us better accomplish it, being whatever that the code requires. And so when we think about that why, we understand that the reason we have an energy code is because we're looking to control the amount of energy being used to, or the amount of heat loss even, that's we're trying to control that heat loss and the associated energy use associated with our mechanical systems, the illumination expectations, climate control within our buildings, right? We're trying to build a building that has that control in it. And the one thing we always think about every time we talk about energy code, the thing that always gets brought up by home builders associations, by the public, by most code officials, is this concept of energy, of the insulation, right? That we keep modifying these and changing the U factors and R values on a table, and that's how we're conserving energy. Well, when you really look at it, and again, this is Climate Zone 6, when we look at how the energy code very quickly has changed over time, it's not significant, right? When it comes to the amount of insulation we're expecting. Right, we can see that again, 38 in 2009 IECC. By the time we get to the 24 commercial energy code and the 2022 90.1 standard, which should be, I think, is going to be the backbone of our future code, commercial energy code, that number doesn't change. Right, we don't see huge changes. Right, we see the change from the 18 from 18 IECC to 20, from 10 to 20 in our slab insulation, right? But when we look at all the other variables that we see between the current energy code and the code that we're going to, the newer version of the 98.1 standard, really the only thing that changes it in the energy, in the insulation, is this concept of the mass wall, right? Because what we've recognized over time is that it's less a question of what we put in the wall, but how well we put it in there. And it's about making sure from the beginning of the process, from plan review, that we focus in on this concept that if you're going to do it, and again, this is something my parents taught me as a kid, if you're going to do something, do it well, right? From the beginning. If you're just going to lackadaisical do a project or do a sport, then don't waste my time. Right, I am probably the worst parent in the world, because that's what I tell my kids to this day. If you don't want to do it, don't waste my time. Right? I love you. I want to be there to support you. But if you don't want to do it, if you're not into tennis, then let's drop it like a bad habit and don't waste my time. And the same concept comes when it comes to construction, right? If we're going to do it, let's do it right, or don't do it at all. And we understand that there is an importance in our insulation. That's Climate Zone 6. This is Climate Zone 7, right? Again, we don't see huge. Actually, look at that. You see a reduction if you go to the 22 versus the 2019. You see a reduction in that R value for the mass wall versus here we saw an increase, right? And so again, the insulation is not so much that we're increasing it, improving it, adding to it. It's that we're expecting that the building will better use the energy because we've provided proper control over our conditioned space, right? The window itself does not use energy. The insulation, the drywall does not, the exterior cladding does not use energy. But what they do is they provide that level of control, that level of separation between the exterior environment, which we know is can be temperamental, we'll call it that, right? And what we're trying to accomplish inside. Now, I think, and I know I saw Chris on here earlier, and I keep picking on him, and I apologize for that, Chris. I don't mean to pick on you in this context, but I think the work that Chris is doing in the mechanical tag is really the most important thing that we do when it comes to the building itself, right? We stopped arguing about what is a 2x4 and what is a 2x6 years ago, right? We allow for mechanical designers and our architectural designs to be different. We allow for that flexibility in whether we use wood or steel or heavy timbers and those kinds of things. But the thing that keeps being discussed is the concept of the mechanical system, right? There's only so much you can do with light bulbs, right? There's only so much we can do with switches for lights. But the mechanical system is the one thing that affects our buildings the most, whether that's residential or commercial. And so I think that's where giving the best control envelope to that building allows us to then have that flexibility to design a mechanical system that heats and cools as we see fit, right? In the conditions that we want. And so it is that relationship that makes insulation so important. It's why that building thermal envelope is a pillar of energy code compliance, right? And when we think about the future of the 21 or not 21 of the residential code, again, there's only so much you can do with insulation. There will not be an R100 in the wall. That's not needed. We've seen that in code development. There's a place where diminishing returns. And so we see the things coming into alignment to where this is probably the envelope you'll have forever. And in most projects, that's the reality, right? And so it's really understanding that relationship and where plan review comes into it that I think is the fundamental thing we need to accomplish today. And then, like I said, I have a bunch of slides, and so feel free to ask questions. We can jump around, or again, I'll barrel through it. So a project starts with this idea of what are we expecting in our construction details, right? We know the code, again, whether we look at 1305 or we look at here in 1323, we have certain expectations. Now, one of the things I think is fundamentally needs to be reinforced is that we need to identify the testing and testers from the beginning. The code tells us this. This is part of that process, right? If I know a test is coming, then I'm going to be prepared for it. If I know what that test is, then I can think about it. If I know who's doing it, I know when to call and who to call, right? So these are concepts that we understand. And as plans examiners, that's one of the opportunities for us to say, what is the standard we're testing against? Not just, yeah, we've picked this firm to do our testing. Well, what testing are they doing? Is it matching it with a table or matching it with the energy code as far as maybe something as simple as air changes per hour? Or is there another standard that we're using? Is it a 380? Is it an 850? Is it a ResNet, an ICC, is it an ANSI? And what is it that we're actually testing against? Now, I've told you before, my wife is a teacher, and one of the things we talk about all the time is not just testing to test, but testing with a target in mind. What is the outcome that you want, and how do we get to it? And so again, that's where we see this role of as fundamental in the beginning of plan review. Now, I know we talked about it again. I got to move on. This is about insulation, not just about that. But again, it's fundamental. If I'm testing for the envelope, that envelope is not just some magical air bubble. right? This is not the boy in the bubble kind of scenario. We're putting in insulation to facilitate that control vehicle for our thermal envelope, right? The second thing that we recognize is compliance path. Now, I did a project this morning for plan review, and I wish this jurisdiction had adopted the code that requires the energy code compliance path be identified, because it turned my life into terrible fun, right? There's no identified compliance path. So then I'm looking at the entire 296 pages of this document saying, okay, so where's my thermal envelope? What's it made of? And how do I verify it? And then attached to that was a com check, which com check we'll talk about here in a little bit. And in that com check, it talked about compliance with the ASHRAE standard. And so when I start going through and applying that standard, it doesn't make sense, because I don't think that's what they're actually complying with. I think they clicked the wrong button here somehow, because there was a lot of details that were missing, right? But identifying that compliance path is going to guide us in what we're expecting to see in our insulation, right? We know that in the compliance paths, there are 3 types of compliance paths for new buildings. They're going to be the what we see as item A here, which is going to be our prescriptive compliance, right? Follow the table, do what the code says, look to the code for your responses, for your prescriptive requirements, right? Then you have the energy cost budget calculation, which is when you're looking at how much is it going to cost to accomplish this, to operate this building for a year versus a reference design. And then you have the Appendix G performance rating, which is, again, another calculation just not on money. It's based on operations, right, and operational efficiencies. Now, I'll tell you, these are as we get further along in this conversation as a state, I think you're going to see people going more towards the energy and performance rating. Now, I don't know if you guys currently track the percentages between the 3, but I tend to see more people start to go towards these alternatives, just because it's more of a holistic approach to evaluating a system's design. But again, I love a good performance or prescriptive plan, because it's just as easy, right? I know we saw the table. I know what I got to put in the wall. So I build a wall that's perfect, that's going to properly insulate, and then I just have to worry about what the mechanical system is inside it, right? And where things go, and make sure that things don't poke through uncontrollably, right? We can control. It's just like that bubble, right? And you guys ever seen that thing where they take the blown up balloon and they stick a needle through it, and some people can do it and some people can't, right? Well, that's because some people have control, and then some people are like me and just stick the needle in there and it just pops, right? Same concept when it comes to installing items in context with our building envelope and our insulation. But going back to what we're doing, we're checking not only that we have the appropriate code edition, which I think is important, right? I get a project, the project got this morning, said it was a 21 energy code. Well, guess what? It's not, right? It's been modified. I like to know that this is that you recognize this is the Minnesota Commercial Energy Code, not the ASHRAE 90.1-2019, because this tells me that you've taken into account, or at least thought through, the fact that there may be specific modifications like we know take place when it comes to climate zones, right? And then we see here identified an energy compliance path, which again, it looks good, but we know is not perfect. And so what we're going to do is, as we review the project, we start to see different things show up. If we see a com check, if we see some type of energy modeling report, then we start to ask ourselves, well, how does that match with what I've got on the paper, or what my compliance path is? Because my compliance path is telling me on the plans, this is what's going to happen. And I know as a plans examiner that what I put on what ends up on the plans is the only thing my inspector is going to have, right? He's not going to have my notes or my little writings about what happened on that plan, right? He's only going to have what's on the plan. And so I start to question things. And one of the things I will always send a comment back on is making sure I have adequate understanding of the compliance path, right? Please specify that of compliance path, because I'm basing this review based on a prescriptive compliance using the R value for your envelope compliance. If that's not correct, you need to make that correction for me, because that's what I'm assuming because I don't have all of the details in this. This just tells me there are compliance paths, right? We saw that section here, 4.211. You're just telling me it's a new building. That's all you're telling me with this number. So I'm going to need that extra little bit of information. So once we've gotten in, after we've passed beyond the compliance path, now we start to identify that thermal envelope. And what are we going to be looking for? Right? There are certain things that we've talked about. We know we're looking for in insulation related components. And the first thing we're looking for is that envelope location, because we're going to see that envelope may be very simple or it may be very complex. Now, that envelope is designed by the building code. The exterior wall envelope is designed to protect us from the detriments of the exterior environment, right? That's the envelope that we talk about the wall envelope. We're talking about an envelope that protects us from rain, from snow, right? From the wind. When we go to the energy code, that's when we take it that extra step further. And I hate the term building envelope. I prefer the term thermal envelope. You'll hear me say it a million times that way, because it's a thermal envelope that allows us to separate conditioned spaces, right? So that if I have a conditioned space versus a warehouse that's semi-heated, then that thermal wall separate, that thermal barrier, thermal envelope separates the two and allows me to have that control over what's going on, right? When we look at it on a large building, we may see the building envelope is, again, that structural component that separates and carries loads and separates exterior buildings from interior spaces, right? Occupiable or habitable, potentially habitable space. That thermal envelope is going to again be the thing that separates it even further into what is conditioned, what is not, right? And how am I controlling these things? And again, that's critical when we start to talk about commissioning and blower door tests and designing a system. If I'm designing this 2-bedroom deluxe apartment and don't have good adequate control over my thermal envelope, then I might start this unit may start paying for and heating and cooling this resident storage locker. So this may be completely occupied conditioned space. This may be semi-heated space, and this is unconditioned space. I need to know that so that I know what I'm looking for. Because what we'll see in the code tells us that we need to recognize and separate these things. But then more importantly, it gives us, you as the building official, the authority to say, yes, this is a semi-heated space. This is an unconditioned space. It's not just you said it. I have to agree to it because I need to know what it is. Because, well, if I don't have that level of control, we all know what happens, right? It gets built as a semi-heated space, and then 3 weeks after we give them a C of O, they start moving in the secretary and and everybody from the IT department goes out into the annex, right? And so that's why it's important. We recognize semi-heated space. We know what you're doing, so that there's no issue of potentially somebody trying to again create an unsafe environment, right? If we know it's semi-heated, everybody's on the same page. If it's not, and you start shoving employees out there, then we're going to have an OSHA conversation that none of us want to be a part of, right? And again, we understand those expectations. So again, we may have a building that has different types of conditioning, and that's where the thermal envelope is important to understand. Beyond that, it also allows us to recognize different types of functions within our designs, right? We know that if a system is completely within the building's thermal envelope, then we have relaxed expectations regarding the insulation of the duct systems, regarding the duct leakage associated with the duct systems, right? If this envelope, dips down, curves around, does some things, now I need to start thinking about things. Where are my different components? Where are my sprinklers in relation to this thermal envelope, right? Where are my different components? And so again, I need to know where that envelope is going to be. After knowing the envelope, I need to start thinking about what makes the envelope, right? Now, I do want to point out that the code addresses envelope alterations, right? Is a parking garage considered a semi-heated space? that will that's the beauty of this code, right? That's up to you, right? Because the space may be designated either heated. I'm going to go to the one that's actually got the state seal next to it. May be designated as either semi-heated or an unconditioned space only if approved by the building official. So again, depending on what they're trying to accomplish in that space, it may not be, right? You may have a semi-heated space where maybe they have some type of, you may have an environment where you're going to have a little bit of controlled heating. I typically see most places have a semi-heated. They have a sprinkler system down there. They need to maintain, again, above freezing, right? And so you may have parking garages that qualify. It just depends on the scenario, and that's why it gives you the authority to say this is conditioned or semi-heated space. It may be a completely different zone as well. You may call it conditioned, and it's just not conditioned to 65 or 68 degrees, right? You may identify it that way. But again, that's where the beauty of the system is, that you make that determination, and in the design, they're making that claim, right? Otherwise, I would treat it as again, based on what's going on in it. Is this just a parking garage, or let me go back to the picture, right? Is this just a parking garage that goes below, and then there's no access, or is there access? Well, this is going to have some kind of an access area, and so we're going to have stairs. We may have some storage. We may have some things down there. So this would, for me, probably be a semi-heated space up to a certain degree, and maybe there's an overhead door. I know that I was in where was I? I was in Arizona last week, and when I went to a parking garage, they had the overhead door, right? If you go to the Hilton down in St. Paul, they've got an overhead door that's not just a chain; it's actually actual acrylic panels to create a semi-heated space, right? So that would be a semi-heated space. Digression. Good question. Answer live. So when we start thinking about that in that context, remember there are certain things that we can make alterations to. The code identifies that alterations shall comply with the requirements of Section 5 for the insulation, the air leakage, and the fenestration. Applicable is to that. I had a building heated to about 45, 50 degrees with precast concrete above. What would you ask for to separate the garage from the residential units above? So what I would tend to think, yes, there was. Let me grab this here. I think again, it would be some level of either some level of vapor barrier, right? Some type of, maybe the thermal envelope has to go across. If we look at what the table says, we'll zoom in. You're in 6, right? So that floor would require an R38 to separate the base, the parking garage from. Now you might be able to get into, again, an unheated, you might be able to go with this U factor or a C factor, because we're talking about concrete, right? And so you might be able to get a thermal rating on the concrete plus some level of, a rigid foam insulation to provide a level of separation. If you don't get that, that's why you see in some parking garages, the stalactites start to form where the moisture is dripping through because they didn't provide proper thermal separation. And then that water, as we all know, will eventually freeze and crack and delaminate or spall that concrete. And again, I've been the guy on the other side of the parking lot who gets presents every once in a while in my city vehicle. Trish, did you have a question? I've unmuted you. If you figure out the thing, jump in anytime you have a question. But yeah, so that's what I would say, Clint. If I want to see what is the thermal resistance of that concrete, that precast concrete, I want to see what is your vapor barrier that's going to prevent moisture from accumulating between that semi-heated space and that heated space that's coming from the concrete, right? Because that concrete's going to get natural conductive heat. Now you may put some level of thermal barrier at the top of it to try to, I use the term shunt, right? When we think about, I'm going to go this way. When we think about the heated slabs, right? Right? When we talk about heated slab on grade, the code requires that we also include, and I've got it in one of these slides, that R5 continuous insulation underneath it, right? That R5 is not preventing heat diffusion into the ground, but what it is going to do is kind of attempt to redirect and shunt it up, right? Over time, you're still going to lose heat to that situation. Oh, okay. No problem. So again, that's what I would, as far as dealing with that, that's how I would deal with it from a thermal envelope perspective. And we've got a couple different examples. If you need one that shows you some examples, we've got one 5-story multifamily with underground parking for each unit and how they did that and what those expectations were on those designs. But again, if we're looking at an alteration to the envelope, it may require that we look at insulation, fenestrations, and air leakage as part of that alteration. But the code always gives us exceptions, right? And it says that the following types of alterations need not comply with requirements for alterations when they do not increase the energy's use. And that's going to be replacing windows, replacing doors, and overall dealing with certain types of envelope alterations, right? When we talk about those exceptions, again, talk about the installation of storm windows, replacing glazing using an existing sash, we're replacing fenestration where we're not exceeding the 25% of total fenestration area, right? Right. So there's certain things that we can do, but if we're going to go all in and replace all the exterior windows, or we're going to, we had a car ran into your building and now you have a hole. Guess what? You're going to have to repair it, right? And then we're going to have to think about what type of window are you putting in. Make sure that window meets the requirements of the code. It's a proper, one of the things I had the biggest problem with, and I've used this example before, when I in the city building I worked in, my window in my office had a crack, right? When they went to replace that window, it no longer looked like the other windows because it was installed based on the new code. And so everybody else had this nice dark tint, and then I had the shiny silver one right in the middle, right? What about the dwelling unit over the overhead garage door? So I would look, Dale, I would probably say we would be looking at what type of door controls are there, right? You can get with the door manufacturer. And so you're going to extend that thermal envelope over the sill, over the top plate, right? And then go back up that wall. And so that overhead door should exist underneath our continuous thermal envelope, right? So if we think about it that way, my envelope is here. I'm going to have that overhead door on some type of a track that's going to be below it. So they're not interacting. Now, does it give it a level of, now that overhead door, like we're talking about in the hotel downtown, again, it was part of a semi-heated space. So it wasn't designed to give complete air impermeability over the life of the building, right? But again, I think that's, if I understand that question right, that's what I think the solution is, right? Your envelope is going to extend across and up to go around that conditioned space, and then your door is going to be below it, right? So we've got the window, we've got the door, right? Replacement of existing doors that separate conditioned space from the exterior shall not require the installation of a vestibule or revolving door as long as that existing vestibule separates, the conditioned space from the exterior, right? So again, just replacing a door doesn't mean we got to install a vestibule, right? I go with the word common sense. We use very little of it in the building code. This is one of those little pieces. Don't tell a tag I said that, right? They do a good job. So that third option is, again, when we start talking about alterations to the roof, the wall, or the floor cavities, right? If we replace the siding, we take the siding off and we don't create a cavity, we don't have to install insulation to fill that cavity. right? If we're doing a membrane, right, where there is no cavity to fill, then we can't fill a cavity, right? If we're doing a roof replacement, if I'm doing a roof recovering, duh, I don't need to do anything. If I'm replacing that roof and now I'm exposing areas that would otherwise require insulation, or that then I would maybe require that insulation. Again, it's one of those, it gives you the ability to have that exception. That's the more important part. You have the ability to grant exceptions to alterations associated with the building envelope. There are going to be 100 different reasons why you would or wouldn't, and the code says you figure it out. Does it fit within the confines of one of these identified exceptions? So I threw that in there just to get everybody riled up. That's what I like to do. You know me. And so with our building thermal envelope, obviously there are mandatory provisions. We know that we have to follow these mandatory provisions. And the first one is insulation, and it tells us that we got to install it to the requirements of the table, right? And then it gets to the fenestrations and door. We know that's part of our overall thermal envelope. We'll talk about that later. Air leakage is going to be another conversation. But insulation in and of itself is that sounds like simple concept that you have to have insulation that meets the requirements of the table. Or you can go with either and that is done through either the prescriptive compliance path, right? Follow the table, or the building trade-off path. And that prescriptive path is, again, follow the table. Jump into it and say, okay, you're going to have a steel frame, a steel joist floor. I need an R38. If you're going to have a mass floor, right? If I've got a concrete floor, then I need a 16.7 continuous or a U factor of 0.051, right? And so you can start to get into, that one thing that I would always suggest, and we'll talk about it here in a second, is jumping to some of the different manufacturers. If it's precast concrete, they know exactly how much the U factor is, right? That's part of their that's what makes them an association, right? When we start thinking about what all's identified within the code, it's these components that we see identified, right? Obvious. The roofs, the walls above grade, the walls below grade, the floors, the slabs, the doors, the fixed fenestrations, and the skylights. And then we start to isolate within them that concept of attic or other. If it's not a metal building, which we talked about a month ago, which was metal skin with metal siding, metal skin with metal framing equals metal building and heavy metal, right? So if we have a metal building, we have expectations, and we know what those are. That requires, we'll zoom in, that's going to require that liner, right? That R30 plus an R11 liner, because we need that liner for thermal separation. If we have that insulation entirely above the deck, that gives us a whole other number, right? We're usually, I think that's an R30 for most, 35 in zone 7, 30 in zone 6, right? And then we have the attic or other. So again, we would take those different components, say, what are those components supposed to be? The prescriptively, the table says I need this number, either as a U factor or an R value. That alternative trade-off compliance path is the ComCheck or other calculation for area-weighted U values, right? ComCheck is literally just going to take the math and do the math for you, saying this is the type of wall, this is what you're putting on it, what is that thermal envelope U factor, right? That assembly U factor. And then it weights it. I think that's one of the things to make sure we understand. When we calculate an R value is individual, one piece of material. The U factor looks at the entire wall system and then averages cavity versus window versus stud, right? Same thing here. So your percentage of window may be different in a different wall assembly. That's why when you look at your ComCheck, it has a wall system and it also has a window. Or you may have a elevation that has no windows. Great, right? That's what we're looking. That's what this is doing. All that math to say overall, this building will have an area weighted based on the amount of wall versus window versus other component, an area weighted U factor of X compared to our tables, right? So again, this is that alternative. And so The reason we have these alternatives is because we understand that not all insulation is the same, right? It all does the basic concepts of the two basic concepts of resisting heat transfer, but not all insulation provides air control, right? That's why sometimes we need an air barrier or a moisture barrier, right? And then sometimes we don't because of the selection of material. Because different types of material, like our rigid foam, spray foams, batt and blown, provide different qualities, not qualifications, qualities, right? They're measured differently. There are different ways to measure. We can look at it as an individual R value, right? We can take the assembly as a whole using a U factor. Either way, we can calculate what is that thermal resistance, how much heat goes through this material over time. And they do that through this little thermal transmission system, autoclave process, right? They can stick the material in, they run the computer, they run it based on the standard and say this much heat transfers in per inch over this time period. That's how we get that R value in the relative U factor. These values can be measured. You can do this on the computer. You can do this with a book, with a piece of paper, right? We've talked about this before. The method of calculation is we're looking at all of these different assemblies, right? We can either identify them one by their R value, right? We see that a half inch of wood sheathing is a 0.81 R, right? We see this 1 inch of insulating board is 3.5, our 13 batt insulation for our wood or our wood stud, which is 4.5 based on its depth and density. We can do the math. We can calculate based on the design of our building. If we're doing 16 on center or 24 advanced framing on 24 on center, that changes our framing factor, right? And that affects how much is wood, how much is wall, right? I got those back. Wood, wall. And that gets us to a number. Then we get down to this. So we, using that simple example of a 3.5 and a 13, we get a 0.058. Well, then we can start playing with it. We can start replacing that batt insulation, right? That number. And so if we increase it from 13 to 15, then we can see how that relative U factor goes down. So more insulation, less heat loss. So this is thermal resistance. This is thermal loss. So the more we have, I usually say this, the bigger I get, the less I lose heat, right? So I'm going for a record here. But I can replace that R value in the cavity in impact. So we see here we got an R20. I'm going to use this as an example. R20 and 3.5 gets me to a 0.045. You can also go the opposite direction and say, okay, keep your R13 batt insulation. Just change the insulation board, the continuous insulation. And so we can start to change that number, right? And if we go to an R10, we actually get more thermal resistance than if we took and went to an R20 in the back, right? So adding 7 here is roughly equivalent to adding 7 down there, right? In this particular design. And so again, we can take those numbers. Let's say I'm designing or I'm thinking about what I'm trying to do. I can go back to my table and say, this is a wood frame wall. I can either do 13 with 7.5 continuous. I could do 19 with 5. So, right, I could have gone, if I'd gone with my 20 plus 3.5 from a prescriptive requirement, from an R value calculation, I still wouldn't pass, right? But I would have exceeded, I would be under the maximum assembly U factor, right? So again, that gives me that flexibility. I can choose either the U factor or the R value, whichever one gets me into compliance. And again, those values are accomplishing the same thing. They're looking at how much heat is transferring through that material. And remember, not all insulation is the same, right? Again, it has to be tested. And when we look at that testing process, I think it's important to understand that we can look at the testing parameters the same way we do with an ES report, right? Or any other material that we start to evaluate. What was the evaluation report on this? What was it testing? Is this material going to perform the way we expect it to? Right? Manufacturers provide a bunch of technical resources to assist in that calculation. Again, if we're doing preformed concrete, the Concrete Association will have that. ACI sent in my state sent us a big, huge thing about how we need to incorporate or allow for the incorporation of fiberglass tensile uh, fibers in mixed in the concrete because it provides added tensile strength and a level of thermal resistance, right? So they made this whole the association generated the material that then we can evaluate and say, does this make sense in the best interest of our communities, right? So you can look at those resources. You can also identify resistance values through the standard itself. Go back to Appendix A. It's got a list of pre-calculated assemblies, right? So maybe there is a floor system that incorporates the thickness of the concrete and again, the addition of maybe some air barriers or foam board insulation, right? But remember, each one of these different materials has a different expectation, different qualities that may make it more valuable in a particular design. And so that's where, as a plans examiner, I need to know what's going on, right? We're not just saying throw an R19 in the wall. What are you telling me R19 insulation, or are you telling me R19 backed or R19 continuous? Because you may be, as a designer or a designer, maybe thinking about multiple things, and I just can't say, well, as long as it's a 19, we're good. I want to make sure that what my design is allowing is what my inspector is able to see and accomplish out in the field. And again, spray foam, we know there's different types of spray foam, whether they're low density, medium density, high density. Low density is that what we call open cell. Again, over time, it cures a little slower. So it opens up the cell and the gases evaporate, which is then allows it to be filled in with air, makes it less air impermeable. You can still get a good air barrier, but you have to install more of it than if you go with a closed cell. A closed cell cures faster, so it traps the gas inside the cell, and therefore you have that information. Are they not equal? So the R factor and U factor are generally the same. Eugene, because the question is whether you use the R factor or the U factor calculations, are they not equal? The R value is looking at one piece of the pie. The U factor is looking at the whole pie, right? And so if I use the example of Taco Bell tacos, right? Am I looking at the meat or am I looking at the taco, right? It's still meat in there, but am I getting the whole taco? And how much better is the whole taco than just the meat, right? So they are somewhat related. Now, so the U factor, the U factor is what comes first. The R value is a mathematical inversion of it, right? Except you're allowing that area weighted component. You're understanding this is part of an assembly versus an individual material. What about if there's a metal frame with metal skin? By skin, do you mean metal siding over wood or drywall sheathing or an actual metal sheathing? So the way the code defines the metal wall is that it would be a metal superstructure with metal skin. Now, I assume that you could put some type of drywall or wood sheathing in between the metal exterior siding and the metal superstructure, but that would be no different than putting in. I think it would still qualify as metal building. It would just be part of your maybe a thermal break that you're trying to create. Okay. So again, depending on what type of material, we want to make sure we understand, are we doing closed cell, open cell? They are different. They don't just taste different. They are different, right? And again, spray foam is something people are really trying to get a lot of because again, it has different versatilities that they may find more useful. But again, if it's looking to just be an easy filler for maybe a small area that doesn't want to be stuffed with bat, or as part of a air resistive or water resistive barrier. Again, we need to understand those things so that we understand it has to be installed the way we've approved it, so that again it all comes out and is successful on the other side. What we don't want is, well, they said they were going to put in this was, we don't understand that this is going to be part of the air barrier. We allow them to go, hey, well, they just put an R19 bat, we're good. And then the building leaks and it affects how the mechanical systems work, how the blower door works. All those things fail because we changed out, without contacting the designer, we changed out some of that material, right? It's where we're getting that place where do it right, and that way we don't have problems. And if we want to make changes, then double check. Make sure the architect's okay with it. Make sure the design's okay with it. Make sure that it doesn't, again, it's not performing more than one function. It might only be just insulation, and that's fine. But make sure we understand is part of is really my plea. Same thing with blown insulation. We know a variety of blown installations have to have certificates associated with their installation, as well as expectations for how we install bat insulation. And when we see them maybe come in the sign, the integration of other building systems like insulated concrete or structural insulated panels, what are we getting on site and how is that going to match? Right? I could see where we might have a structure that's they want an insulated panel to serve as because it might be easier, cheaper, and faster to buy, right? Or like I saw this at the ResNet conference last week. This is an insulated foam board that also has structural sheathing capabilities. So this is an R6 per inch, right? So that's R6 per inch right there. So you could go with R6 with a structural sheathing, and then have an R6 without the sheathing, and have R12 on the exterior wall, right? And then that you can nail through it. They gave you the list of different fasteners and how deep those fasteners can go in order to get to that metal superstructure. So again, I think you have versatility that sometimes we say, well, this is just being controlling. No, it's controlling the building, not your design or what we're expecting the building to look like. So again, knowing that R value, knowing that U factor is half the battle, right? Knowing that it's there and what my contractor is going to be doing, what my inspector is going to be looking for is half the battle for me as a plans examiner. The other half is making sure that we follow the manufacturer's installation instructions and that we provide those instructions, right? That other side is either meet the tables and then comply with the installation expectations. So what does that manufacturer say is supposed to be done? What is that testing methodology going to be? Are we going to be using a grading system? What are those different expectations, right? We know that the code adds in some or modifies some of those other prescriptive installation expectations, right? Where we increase go from an R5 to the R10 for roof curb insulation, right? We see that both in the 5.5 for thermal envelope under the prescriptive path, as well as 6.11. Now, again, one of the things I'll point out, this is in 5531. This is a prescriptive response. If I choose to go with the simulated performance or one of those other performance passes, this technically no longer applies, right? Which is why we see it added again in section 6 for the mechanical systems, right? Because we want to make sure that those curbs take into account long-term needs of that roof structure. But again, there might be things that we think are going to happen, but if we choose a different path, they go out the window, right? Because all these systems are all reflected in those different designs. I'm going to jump through these next ones because we don't have time. But again, for those of you that have the slides, and when I send the slides back out, they break them down section by section, so you can see that I just used Climate Zone 7, the different values associated with each of these different. That's weird. I've never lost a team before. I apologize for that, everybody. I don't know what happened. Don't ever shake your hands at the computer. It gets kind of, I guess it gets angry. So, but it looks like everybody's here. So again, jumping to some examples. Again, what we're looking for is again, where is the location? We know the code identifies that we need to put that on the exterior side. So when we see it identified on an interior surface, what should we say? No, right? We need to have it on the exterior side or integral to the wall itself. So that again, as a planner, I'm looking for these types of scenarios to respond and say, this does not comply with section 5.533, right? Under the prescriptive requirements. Now, again, we may need to think about, and I don't know what the intention was, but if this is something we want to make first mandatory, then it goes in the mandatory section, not in the prescriptive section, right? Same concept here. So again, if I'm going to install it, I'm expecting it on the exterior, not on that interior side. Understanding when I'm looking for different insulation associated with that floor system. Again, am I looking for a wood, a steel, or a mass wall system, floor system, right? When is it going to be part of a crawl space or some other below grade wall? And what are those expectations? Am I okay with this type of a design that incorporates a portion of above grade, a portion of exterior, and a portion of interior design? Now, again, to me, this is going to be one of those you're going to have to find. You're probably going to go with the trade-off calculation, not a true prescriptive 5.5.3.3 requirement, right? But again, I need to understand this one here shows a building that's got a bunch of different thermal separations we see there. But it's the intent of the exterior walls to be that continuous thermal envelope. We need to know where it's at. So that way we can evaluate each of these systems and see on the plans, are they part of a thermal envelope, right? How does that thermal envelope, this 3.8 and R20, match with my R19 plus 5? Well, if I'm going R value, it doesn't match. I need to see what that U factor calculation is going to be so that, again, can make sure that this matches. A thing I see all the time, a lot of times, is going to be this insulation schedule, especially with bigger projects that have a lot of different details, because they're tired of writing in that R19, R19, R13, right? So they'll put it in this kind of a schedule with the iconography or the symbols to tell you what it means. Again, make sure that that's completely filled out, right? We don't want to have a bad insulation that, what does it mean? We don't know. But part of it is also recognizing, what is it for? Is it there as this bad insulation for plumbing stack sound control? Okay, then it's not part of my thermal envelope. So maybe that's what I need as a note, right? Over here, that this area, this type of insulation is not part of a thermal control. It's part of a sound control. And again, we install things for a variety of different reasons. I know that was a lot of different things to talk about, and I've got some extra slides, but the one thing that we need to think about is, again, how does this all work together to be part of an air control system? So that, because insulation doesn't work alone, it works with an air system, and it's part of that expectation of what we're testing to make sure our buildings work effectively. Next week, we're going to get a little bit more into the concept of the inspection itself. If anybody has any questions, obviously we can stay on, and as long as my computer doesn't kick me back off, and answer any questions. Again, next week we'll be talking about inspections. Hope will be probably doing that because I'll be teaching at the ICC Region 3. For those of you that are going to be at ICC Region 3 next week, Hope is teaching on Monday. I'm teaching on Thursday. Mine's on ComCheck. Hers is on hers is mine is specific to Minnesota. Hers is more of the IECC and ASHRAE together. Again, remember, for those of you that weren't here when I said it earlier, Tuesday, February the 11th, next Tuesday at 3:30 at the Marriott, where they're holding the ICC Region 3, we're going to have our first Energy Code Collaborative meeting. It's going to be from 3:30 to 5. Please let us know if you're interested in coming so we can make sure we have enough food and beverages available. It is free, so Even if you're not attending ICC's Region 3, you can come and participate. There will also be a hybrid option. So feel free to check that, so you can let us know that you're interested and we can send you the hybrid. It's not as much fun. You don't get to sit there and talk to us as easily, but again, feel free to show up. We're going to, introduce some different resources, talk about that. Again, like I said earlier, we have one of our 4-hour in-person free trainings is going to be hosted by Hermantown on March the 26th up in Hermantown. So those of you that might be interested, you can go online, register there as well. Remember, if you ever have questions, you can either email us individually or you can send it to the mnecsp@shumscoda.com. That goes to the entire team. If you have any questions or there's things that we can help with throughout the process, please feel free to reach out through the code helpline. Again, you can scan that QR code, or go to our website and find the contact section. When you leave, you're going to go through a survey. Make sure you give us some ideas of things you might want to talk about, future conversations, that kind of thing. Again, so we can make sure that if there are additional classes, I think one of the things we're going to do is bring back again another deep dive into ASHRAE on like a Tuesday. But if there are other topics, other buildings that I need to be using as examples, or we need to be using as examples, please let us know. We know this is a lot of information, and that's why these plan review and inspection series will repeat every more than once a year. So again, you can come back in and or have other team members that need to participate and get all of your credits for it that way too. If you do have any questions, feel free to reach out to Hope or I or Jim or any of our team. There's my email for those of you that might want it. Again, I hope you had a good time. If you have any questions, please let us know. If you do see me next week at ICC Region 3, stop by, get a little toy doll, get a notebook, and then let's just chat, right? I enjoy chatting more than anything. But you guys have a great week. Be careful. And again, if you have any questions, feel free to reach out to us. I'll stay on for a few seconds if anybody has any questions they want to ask. And if anybody's interested in hosting a training, let us know. We always can set up more trainings. Sharing.